Okay, last week video I already uploaded in YouTube. You can go through it. Okay, so last week we have model this one, right? This building, right? So in last week we already applied the um, all gravity loads, right? And do the analysis, right? So today class I am going to explain to you how to input the wind loads. Then we do the analysis and design. Okay, so let's go to the wheel load. Okay, the lateral load basically is a two lateral we are considering. First one is a equivalent horizontal load or notional load. This one automatic calculate. So we don't need to calculate an input. Wheel load only we have to calculate an input. Okay, so I think most of you are familiar how to calculate the wheel load, right? I'm not going to going through how to calculate wheel load. So bin loads you had to calculate based on the EC1, right? So based on the EC1, there's a formula how to calculate the bin load. So if you calculate the bin load, so normally what you want to calculate is a bin pressure, right? Pressure varying based on throughout the height is varying, right? Okay, there are some rule of thumb, right? I am going to use it because these are low rise. So let's say your beam velocity, right? Maximum velocity is around 30 millimeter per meter per second, right? That means 30 meter per second cut speed, 3 second cut speed, right? Beam processor is varying zero point 0.5 to zero point 0.6 kPa, kilometer per meter square, right? So this is a calculation you supposed to carry out. So if you are not familiar, give me a minute. I open one Excel sheet and show you how to do the calculation, right? Give me a minute. Okay. I believe most of you are gone through this bin load calculation in your university, right? So this is a code. Okay, SS is Singapore, so you can follow EN star BSEN, right? 199 dash 1 dash 4, right? So basically what you want to know is a basic bin speed, right? For Sri Lanka, your region, how much bin speed you want it. Or if you do the design for other country, basically you want these parameters. Basic bin speed at the particular site, how much, right? So if you know these parameters, then others you can calculate based on the Eurocode, right? So I'm not going to go through this one, right? I just do simple calculation. My building is 8 meter, 12 meter high, so I enter 12 meter, right? So width, right? Is how much my width? Let me see. Uh, from here to here. So grid lines. 1, 2, 3, 4, 24. 1, 2, 3, 4, 36. 24 by 36. 24, 36. Right. So wind pressure is around 0.65 kPa, right? I can assume 0.65 kPa. Okay. So I'm going to assume this value, right? Okay. 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 Now you can see my model, right? So my bin pressure is 0.65 kPa, right? So throughout the height, I am going to use the same bin pressure. Okay. So what you want to take note is bin load you can apply only on the 3D view, right? Okay, there's a many way to apply the bin load. I'm going to explain to you two way, it's common way. Those two ways you can apply only 3D view, right? So another way is a manual input. That's when you can apply in the plan view or in the section, right? So last week we see, right, how to apply the vertical load, gravity load, right? We had to go to load menu. So under load menu, we had to apply the area loads, right? Right. We had to select the flow and we had to apply the area load, right? So before that, what we want to do is we had to create the load cases. So I'm going to create the load case first for to apply the wind loads. So I add the new load case. So this one I call wind X. Okay, X direction wind. I call X. So type of the load is wind, right? So I add the another case. So it's I'm going to call wind Y, right? Okay, actually, if you want to apply other direction, right? Normally, if your building is not symmetric, then you're supposed to apply wind X direction negative also. But here buildings say symmetric, right? So I'm not going to apply the both directions. So I'm going to apply only one X and Y only. If you want, you can apply X positive, X negative, Y positive, and Y negative. It can be done. Or other way is combination. When you do the combination, you can minus it. That's also another way to do it. But this building is symmetric, so I'm going to apply only two directions. Okay, so I already apply create the load cases. So I am going to apply wind X. Wind X means this way. See this one X, so I am going to apply the wind load this way. Okay, so now you had to come under wind load, right? Actually it's a wind wizard. This wind wizard also is working, but problem is this wind wizard, right? If you want this, if you want to use this wind wizard, right? Sri Lanka is supposed to be inside this software, the topography. But I think only UK currently they have only UK. So I think we cannot use this wind wizard. So we had to apply through the simple wind load, right? So I'm going to explain how it's working. So what is working is, right, normally they take this width. Okay, this is at overall width. We are going to apply the wind load, right? So what they do is they apply the wind load at the center of this building. Then, right, then it's distributed, right? So in order to understand this one, you have to understand the diaphragm, how diaphragm is working, right? Diaphragm. Okay, see. Okay, I do again. Come to the review menu. You can on or off the diaphragm, right? Right. So now you can see that, and now you can see the color code here, right? This is included. This one excluded. Okay. So I explain to you. Okay, these all are considered as a diaphragm. So all these steps included in diaphragm. Okay, so this one also actually can include. So you could select this one, right? So so in order to do this one, so go to first or any levels, select these steps and include in the diaphragm. It's already included. Why is showing not included? Okay, let's see in the 3D. It's already included. Okay. Okay, so you can check this whole thing is a diaphragm, right? So if you apply the will load, right, it will be applied on the center of the diaphragm, right? So that means if you apply along this width, right, so it will be applied at the center of this diaphragm. So this whole plate consists of one diaphragm, rigid diaphragm. So it will be applied at the center of this diaphragm. So each flow is applied at the center of the diaphragm. So that's the way we are going to apply the wind loads, right? So basically the wind load is transferred to the core walls, right? It transfers the core wall. So if you apply here, so this flow acts as a diaphragm to transfer the core walls. Core wall transfer this load to foundation, right? After analysis, you can see all these corresponding loads, right? So now I am going to apply the wind loads. So in order to apply the simple wind load, first you had to select the load case, then click the simple wind load. Now look at the screen. Is ask you to specify the starting point, right? So I specify my starting point here first, then end point here, right? So now it's a whole width is already taken right? So if I already taken the whole width, this is my distributed area, right? So see here, apply to where we want to apply the loads, right? So diaphragm or panel. Okay, this panel I come later. So now I'm going to apply the diaphragm. So I select diaphragm, right? So now we had to select the levels. We have three levels, right? Story one, two, three. So I'm going to add two more levels, right? So the first level, top level is 8 meter height. Second level is 4 meter height. Third level, zero. Story one is a zero level, right? This is a foundation. Foundation level we don't need to apply, right? So this one I am going to apply uniform, right? So you can, based on the code, you can calculate different pin pressure and you can apply different variable pin pressure. But at this moment, for simple, I am doing equal pin pressure throughout the building height, right? Throughout the building height, I apply the 0.65 kPa pin loads, right? So I apply OK. So now you see this simple, right? So it's apply at the center of the diaphragm. So you can select this pin pressure also. If you want, you can select it. So but now you're gonna change it because this we apply it, but it's still not decomposite. Later I saw you what is a decomposite. So it's not decomposite. So you're gonna change it at this moment. Okay, so this is a wind X, X direction wind pressure, right? Similarly, we can apply the Y direction, same way, right? Click the simple wind, right? Select the first point, select the second point, same way, right? So you had to enter the flow and enter the wind pressure. Okay, right? So now we have applied, right? Flow, each floor, three floors, we already applied. Right? So if you say if you don't want this one, right? Let's say if you don't want, you can delete it, right? Then go back and only apply the two floors if you want, right? So and below 8 meter, 4 meter, 0.65, 0.65, right? Okay, right? So you can apply here like this also can, okay? Or other way, if you want, if you don't, if you want to avoid the foundation, right? What you can do is, right? This one you can make it 0, right? So this is 0.65, right? Throughout the height is the same anyway, right? So it's a one pin, right? So this is a way, right? So if you want to apply the varying wheel loads, each floor you can apply it, or it's the same pressure you can apply the throughout the building is the same, right? It's a many ways you can apply it. Okay, if you want to change it here, right? This one, right? I delete it. For example, I do this way throughout this height, right? So I make it this one 0, right? I apply one level below, right? Sorry, this one I can delete it. This one 4 meter, then 0, right? So this one I make it 0.65, this one I make it zero point 0.5. Example, zero point 0.5, right? So now you can see we can apply two different mill nodes, right? So it's depend on your design and the mill node calculation, you can do it, right? So now I already apply the mill node. X and Y I already applied. So what we want to do now is we had to create the load combination. Last time we create the combination only for gravity load. Today I'm going to add some more combination for the wheel load. Okay, so the similar way, I am going to generate the will node automatically, right? So I don't want to include the accident or seismic. I want to include only geo combination because this one I can do I can do for my foundation design. Later I explain how to do the foundation design. So this geo combination is we need for the foundation design. So I leave it. So okay, come here. If you want to consider this case, then click check because WG means wind. Okay, then your combination also I tick it. Okay, next. Okay, this one is all I standard. I don't want to change it. Okay, now look at it. Each direction, right? Direction one, direction two, we had to include it, right? So you see, say direction one positive, direction one negative, right? So I'm going to include all four directions. So last time I told you, right, we don't need to apply separately. So we can include the wind pressure in the um, combination. If wind pressure is the same for both directions, then we can include in the combination. We don't need to create the new load cases for the negative direction. Okay, so now is create all the wind load combination, right? So we don't need to bother. Actually, software automatically calculate all the wind pressure. So you can see, right? So there's so many wind pressure, load cases, right? Because we have many load cases, so it's calculated for the, it's created for the each combinations, right? Okay, so there's a many combination, right? So it's very hard to read each and every combination, right? So in order to make our design easier, right, I'm going to create envelope. So I am going to create two envelopes. First one is called, I call is a Saksara or strength combination. So I call STR Saksara, I call Saksara combination, right? Second one is I am going to call geo combination. This is for basically for the foundation design. First one for the member design, second for the foundation design. Okay. First one. Now I had to select the low case, low combination. Which combination I want to include in this envelope. So I create for all STR. So select all STR, right? Click OK. Then geo. Similar way, I'm going to include all geo combinations. Okay. Okay. So I create two envelope so we can easily see our analysis results. Okay. Now is we already applied the loads. So let's go and do the analysis. Before analyze, right? We suppose to verify the um, models, right? So this one called as a validate, right? So you can see this one I can call validate, right? This option, you click validate, right? So after validate, you can see here, right? This model geometry is validated, right? Okay. If there any error, is show the error. There's error, so we supposed to correct it. Okay. Now let's go and run it. Right. We had to select all combinations. Just make sure that all combinations are selected. Okay. Click OK. Okay. Now building analysis done. So we go and see the results. So I choose a frame, okay, because the deflections or any actual forces we can see on the frame only. We cannot see on the plan. So which one we want? Okay, I select the frame one, that elevation one. Okay, so elevation, right? So now we had to see the results, right? So right click on the screen and select results view, right? Go to the results view. So we had to see the results for the Windex, for example, Windex, right? So I select Windex. So what we want is, let's say deflections. I want to see the deflections, right? I select deflections. So now you see there's a deflection. It's showing, but I cannot see it, right? So we had to increase the in the magnitude, we had to increase it, right? So now you can see, right? So there's a deflection. It's a small deflection. That's why we cannot see, right? So these deflections are small, right? Anyway, our wind pressure is not big, so that's why our deflections are small, right? So maximum deflection, see how much? Only 3.35 mm, right? So deflections are small. So if you want to see Y deflection, right? You choose a frame A, right? Choose a frame A. So similar way, choose the results view, go to the deflection, click deflections, right? So here you have to select the load cases. Okay. Now you can see, right? Deflection is maximum is 1.47. So if you bring the cursor to the node, right, you can see the deflections, total deflection, how much, right? So the top floor 1.47. So story 2 only 0.84. Story ones is almost zero. It's very small value. Okay. So now you can verify your deflections if you want. Okay. So similarly, okay, if you want to see the axial forces, I think last week I already explained, I explained again. Let's say for the envelope cases, right? So if you want to see the axial forces on the column, right? So go to the axial force. Okay, 1D results, right? Axial force, right? Click axial force. Now you can see the axial forces diagram, right? If you want to see the text, right, go to the text here, right? So forces, click the forces, right? So now in the screen you can see the forces. How much forces? It is 441, 461 kilonewton, 930, 938 kilonewton. The foundation 1400 kilonewton axial forces on the column. So your maximum axial forces on the particular frame is 1413 kilonewton. Okay. If you want to see the geo combinations, just select the geo combination, right? So see here the values. Understand? Okay. If you want, similarly, if you want to see the bending moment, right? Go to the 1D results, choose the bending moment, right? You can choose major, right? Minor bending moment very small, so choose a major. So now you can see how much is a bending moment, right? So if you want, you can change to success and see the bending moment how much, right? This bending moment looks small because we have chosen the frame A, right? This is a frame A. So this frame A actually there's no much loads. We didn't apply any loads. These are one way slabs. So that's why it's showing the very small bending moment. So if you go to frame one, actually you can see big bending moment. So choose the bending moment, major bending moment, mm, right? Major bending moment. So we had to go to envelope, right? Okay. Now you can see the bending moment, right? So choose the text. So you can see the results, right? This around for 557, 527 kilometer meter moment, right? So okay. Right. So similarly, if you want to see the axial forces, you can see the axial forces. So if you want to see the moment of the column, you can see minor moment of the column, right? So if you want to see the CF forces, you can view it, right? Uh, then okay, I think that you can see the CF torsion moments. Okay, this is very small. We don't have much torsion. You can view it, axial force. Okay, so you can be basically you can see all your results on the screen, right? If you want to print it, just right click. You can take the screenshot. You can save these screenshots if you want, right? Okay, so now you know how to see the results, right? So all bending moments, axial forces and shear forces, you can view from here. Okay, so in case if you are doing the steel design, you supposed to want to know the beam end results because the connection when you do the connection, right, you want to know the how much force transfer impedance beam to column. The beam end results also you can see here. So if you click Bman, right, Fy, basically say Fy. So you can see here how much is the force here. So if you want to see other results, right, axial force, let's say axial forces. There's no axial forces in the beam, right? Basically no axial forces, right? I stop these results. Okay, okay. So beam end results. I saw major, right? So major process here. Okay, you may ask me why there's a two results. Because I have because I choose the envelope. Envelope means normally so maximum and minimum, right? So it's there because there's a lot of combinations, right? So it's showing the maximum how much and minimum how much, right? So maximum 233 kilometer, minimum 134.6 kilometer. So that's why it's showing the two results. You can see here also always. Okay, in the envelope you have to keep in mind always show the two results, maximum and minimum. So if you choose any combination, then you can get the absolute value. So it's a one value, just only one value, right? Okay, you can see only one value, but when you choose the envelope, always you can see two results. Okay, that's what you have to keep in mind. Okay, so this way, if you are do the steel design, then you can extract your forces from this analysis, right? Similarly, if you want to do the file design or anything, then you can see your reaction, right? How much reaction? So it's under reaction. How much is a reaction? So you click reaction, right? So you should have to choose how much, what is the rejection you want. Total means it show everything. I don't want to see everything, so I want to show only the vertical. Let's say vertical. So here you go to the text and select rejection. So now you can see the reaction, right? So if you want to do the file design, you have to call geo combination, right? The guy is showing two results, minimum and maximum. So you're supposed to do the maximum to do it. In case your column subject to any tension forces, then you can see the tension. So it's good for your design. Is there's column subject to tension and compression for the various load combination. The one view you can see how much is the maximum tension and how much is the maximum compression. So you can design your file for both cases. Understand? Okay. So basically, I already cover how to view the reaction, how to view the beam and forces, how to view the 1D results. But basically, 2D results you need only for the slab design. Slab design means flat slab design. It's not one base beam slab design. It's a flat slab design. So if you do the flat slab design, then you can see the 2D results. Okay. Okay, now I close this one. I don't need this one. Okay, so I already capture how to do the modeling and uh, how to do the how to see the how to view our results, right? The analysis results, right? So now let's go and do the design. Okay, so let me explain how to do the design. So all designs, right, cover under design menu, right? So first one, what you want to do is you have to look into setting, right? So it's a default setting. You may not need to change it, but it's better to review, right? So I think last week I explained, right, what building mode I choose it, right? So go to the SCORM menu and select the model setting, right? Just look at the design code, right? Make sure that you have chosen the correct design code. Okay, I I choose UKNX, BSEN UKNX, right? So then I can go ahead and do the design. So now let's go to the design menu, click the setting, right? So I'll go through one by one. Analysis, right? So we have already done first one analysis, right? So I'm not going to capture these ones. These are advanced things. So I'm not going to capture, right? Here you see auto KM formula, right? So basically what does mean is in case you are building a cylinder or it's normally this one good for a steel design, right? So I think those familiar with the steel design, you know what is alpha CR, right? Critical value, right? So in this critical factor, you can calculate manually also, or you can ask software to calculate it, right? So your column moment can be amplified using this value, right? So this one normally not no need for the concrete building. It's more suitable for steel building or cylinder building, right? This is more advanced topic, so I'm not going to cover here. So if you are interested, then you can go and learn it. Okay, so basic analysis, we choose the first order analysis, a simple one, right? So you can see the conditions within bracket there. Our alpha CR should be more than 10, right? So then only I can do the first order linear analysis. Some people normally ask me, right, how you choose the first order analysis or second order analysis or whatever, how we can choose it. Basically, it's based on the slenderness, right? If your building is not cylinder, it's a stocky building, right? Then you can choose the first order analysis. That's why your building is cylinder, then you have to choose the second order analysis. Okay. Then question is how to choose, how to decide whether our building is cylinder or non stocky. This one is some advanced topic. We are called as a buckling analysis, right? I think you are familiar with the local buckling, right? How to do the buckling, how to do the local buckling analysis for the steel column. But this one now I'm talking about the global buckling, right? This is something advanced topic. So if you are interested, then you can go and learn this. What is the buckling, global buckling analysis, and how to calculate alpha CR, right? So based on that one, we can choose our analysis method, right? So this is okay. Anyway, simple regular building, you don't need to worry, right? If you have a very tall column, 20 meter, 25-meter column, and so on, then you have to worry about the slenderness. right? Our buildings are very stocky, so you don't need to worry, right? The simple rule of thumb is your height over width ratio, right? Height over width ratio is more than 4, sorry, less than 4, then your building is stocky. Then you don't need to worry, right? Height over width or height over length ratios less than 4, then you are safe. You don't need to worry about the slenderness, right? So, but if you are, let's say you are doing the similio tower, high, very tall, but with is small, then it may be a slender building. Then you need to do the second order analysis, right? So, simple concrete building, we don't need to worry. So, this one I can go with the first order analysis. Okay. So let's go to the general. Well, general basically, okay, fixed column, not horizontally. Okay. What does mean is, right? Okay, when we do the gravity design, right? Let's say our column, right? I already explained last week what is the meaning of brace column, right? So basically, we are here we are ticking and say inform the software is our all columns are brace. So horizontally brace it. So software take as a fixed joint. Okay, still I'm not going to cover, so I am going to cover the concrete. So before that, I am going to see the design forces. Okay, basically you see here, right? I mark this area. Okay, all this one, right? Actually, it's a ignore, right? If your torsion less than 10, ignore it. No need to check. Axial force on 10, less than 10. Okay, basically this one is for the beam designs, right? Beam design. Okay, because you see, if you start to design beam for the mine axis bending, it's complex, right? So we had to ignore some value or we had to neglect some analysis results, right? So that's where software set the minimum value. If value is below this one, is ignore it. If more than this value, it gives a warning. Let's say your beam exceed this torsional moment. Let's say your beam subjected to 20 kilometer meter torsional amount. Then it gives a warning. So you have torsional moment is exceed the ignorer value. Then you have to take a look. So if you receive this warning, then you have to design your beam for the torsion, right? So you don't design. The axial force also similar. Normally beam, right? You design only for the major bending and major shear, right? So is there any minor bending or minor shear, then you have to design manually. That's why software already have these values, right? So it can similarly you can enter, okay, for slab design, right? You can enter some values below this one, ignore it, but normally we don't do it, so we don't need that's why we normally we leave with these values, right? Okay, so change the color. Okay, this area, right, is minimum forces, right? So let's say sometime some element based on the code we had designed for the minimum forces. Let's say steel design, all bracing suppose the design for minimum 75 kilonewton axial loads. Even though your load is less, you must design for 75 kilonewton based on the code. So then you can set minimum value 75. Even though your load is small, is automatically designed for the 75 kilometer. This one you can predefine it. Similarly, beam also you can predefine it. They define it, so you can automatically do it. Right. Basically, it's good for the steel design. Similarly, foundation, right? If you want to limit the foundation minimum process, you can enter minimum values here. Okay. So these are the basically free settings. You can do it. Okay, so let's go to the design group. Okay, so okay, where in Tekla structure, normally all concrete design they do in group, right? So here actually you can choose which are things you have to do the group design. I first I all untick it, so untick it everything. If you want, you can untick it first. Later I will see how to do the grouping. Okay, auto design. Okay, we allow to auto design. Sway and rip check. Okay, you can predefine define this value. Win rip, how much you want to control it. Sorry, height over 300, right? Normally height over 300, or if you want height over 500, it's up to you. You can decide it based on your design requirement. You can decide it, right? Overall rip, how much height over 500 or whatever. This one based on your design requirement, you can define it. Fire check, we are not going to do it. Timber also, we ignore it. Concrete, I am going to check the Cast Institute. General, let's see the general. So this is last week I already say, right? So maximum normal weight concrete we can go 50 k. This one is a cylinder strength, not cube strength. Cylinder strength maximum 50 MPa. You don't Tekla structure designer don't do any design for the high strength concrete, right? Okay, these are the bar parameters, right? Normally, we don't need to worry too much, right? In case if you want to use a different type of the bar, then only you have to worry. Most of the time, we use a type 2 bars. Our bars are normally completed by type 2. Then we don't need to worry. Our factor is 1. In case you choose a bar band type 1, then you may need to modify it, right? Is if you use a normal BSEN standard bar, right, then you don't need to worry. Then beam. Okay, beam. Okay, basically it's a detailing. How we are going to do the detailing? So okay, country we choose UK, right? Minimum bar size, right? I change it, right? Okay, you see trip type, right? Type 2, right? Normally we don't use type 1, right? Okay, this one I change it. But for beam, right? I want to use minimum bar 16. Let's say I use 60, right? Maximum bars I want to choose 32, right? Sidebar, if beam depth is exceeding 750 depth, right, then we had to put the sidebar. I choose minimum sidebar is 16. This all I define it. It can be changed. It's based on your design. You can change it. This is my preference only, right? It's not the design requirement. It's my preference. Minimum top steel clear cover, minimum top steel clear spacing, not center to center, clear spacing, 75. Okay, reason why I leave it. Minimum bottom so 50, also reason why I leave it. If you want, you can change to 75. Both are 75 if you want change. Maximum tensile steel spacing, right? Is saying 200, I leave it. Okay, it's depend on the crack controlling, right? If you look at the Eurocard, right, there's a values for the crack control, right? So you can look at the chords, right? Based on your diameter, you can decide it. So 200 to me reason also I leave it. If you want, you can reduce it 150 or whatever, you can reduce it, right? So okay, this one the last one is use single bars when beam width less than 150, right? If okay, these are normally no, normally we don't do it, right? We normally we maintain minimum 200 width. In case if you want to use less than 150, then you can use this option. Okay. Okay, this is a short span beam. These are okay. These all values you can change. It's just a design parameter you can change. Okay, then we go to the reinforcement setting, right? So detailing, reinforcement setting done, detailing, right? So the detailing, right? So you have to see uh, longitudinal bar. Use the same uh, size bar in multiple layer arrangement. If you want to use same, then you can tick here, same bar. Use the same number of bar in each layer. If you want to use the same bar, number of bars each layer, use a ticket. If you want, you can do it. Hard length. How much is a hard length you want to round off it? And the longitudinal rebar is a minimum. How much if you want use it? Basically, it's all our Curtiman rules. Normally, you are familiar with the Curtiman rules, right? So you can choose a certain Curtiman rules here, right? So then end support curtailment rules, right? So you want to extend beyond the support, or you have to put the U bar at the end support. This basically all are curtailment rules, right? There's a many way to do the curtailment, right? Normally, I extend the span bar to enter the support. Generally, I do it this one, right? Some people have a different opinion, different curtailments. It's all up to you to decide, right? It's engineer supposed to decide it, right? It's a engineer design, right? Link also similar, same thing, right? Okay. Then top bar arrangement. Okay. Okay. Basically, this arrangement may look strange to do, right? Normally, when you go with a Cast Institute, we may not need to do this kind of the curtailment, right? But for easy purpose, this software using this one, right? That's what we get to understand, right? If you want to change it, you can change your own. Okay, later I show you how to export these results. You after export the results, basically you can modify all these rebar based on your own requirements, right? But this software, they have the three options. Later I show the one by one. First option is this one. This one is a simple one. The top rebar, the simple one. Okay, support T1, middle T2, the right support T3, left support T1, middle T2, right support T3. This is a notation. Okay, the cantilever, when you come to cantilever, in the end it's T2, support is T1, right? So, okay, here, the T1, this one T1, right? So here actually enter minimum. Okay, normally, right? If you have the pin support here, right? You remember last week I talked about this one. The end support I make as a pin, right? If the pin means there's no moment, right? So normal moment means we don't design wise we don't need any rebar, but we had to provide the minimum rebar. We had to provide the minimum rebar. So this one asking the region T1, what's the minimum? So what I am assign is 25 percentage of L. Okay. So this one actually can be changed. Okay. So it is up to you to decide. Okay. Then go to standard two, right? Standard two. If you want to look at this kind of the detail, also you can do it. Right? It's up to you to decide. But basically, it's a drawing. Later on, we produce a drawing. So it's produce a drawing based on this curtain arrangement.
L mean what? The
So sorry.
25 percentage of L. L mean
L means span. The this L means this L means 25% of the bottom rebar. You asking this percentage, right?
yeah, this percentage L mean the span, right?
No. L means span length. This okay, I mark it simple. Okay, this supposed to know this length, right? So I
Okay.
call
Not
L1.
the reinforcement area, right?
No,
It's
not area. This is a
okay, okay,
0.25 times L. L means span. L means
okay,
span. Okay. Okay. So type 3. Type 3 or is this kind of the detailing. This is not common, right? So common thing is T1 or type 1 or type 2. This one, right? So these are the common things. Right. It's based on your things, you can choose it, right? This one similar here, right? Default pattern. Okay. So I leave it to type 1, top, right? Similarly, bottom, right? This kind of the detail. If you want to change, you can change it, right? So I leave it type 1. Okay. So this one, if you want to change, you can change it. It's 25. If you want, you can change it 25%, right? Or you can leave it 15% or 10%. It's change. You can change it. Okay. So link settings similarly. Okay. The S1, S2, S3, 25%, 50, 25. Right? If you want to change it, you can say. If you want to copy the equal, right, you can say 33%, right? All are equal. If you want to change it, right? I leave it standard, 25%. Okay. Link type. You want to use open link or closed link, right? I choose open link, right? Only seismic region we want the closed link. Other region we don't need a closed link. Open link is sufficient. So I leave it open link. So bar size, a link minimum you can go 8 or 10. Okay, whatever. I leave it 8. Or if you prefer 10, you can choose 10. Right. So maximum I choose 16. Right. A link minimum spacing I choose 100. Maximum is 300. Right. Increment is 25 mm. Right. Maximum link leg across the beam. This means, well, let's say I had a wide beam, right? So I had to provide more links, right? So one perimeter link not sufficient, right? This one not sufficient, right? So I had to put the other links inside, right? So this one is a 300. This one 300. So maximum link leg spacing across beam is 300. So if you want to change, you can change it. It's 300 normally is standard. Okay, these all are the things, right? If you want, you can change it. Use single outside link. uh, Generally we use one full link because okay, so it depends sometimes, right? People uh, do the detailing this way also, that's why it's asking. Okay, generally what we do is this way, right? Then we have the link inside, right? But this kind of detail sometimes we have it, or some people they don't do this one. What they do is uh, they have the single link inside, single link inside, not you. So it's asking, right? Accept single link, or if you don't want to accept, you can untick it, right? External link always you save, but internal you can change to like if you want, or if you don't want to accept it, you can remove this one, right? So if you don't want to accept a single leg, then you can remove this one. Okay, let's go to the general parameter. Okay, these all are code values. If you want, you can change it. The maximum aggregate size, cover tolerance, basically is all our code values. Okay, let's go and see the column. Column also same. I choose minimum 16. We don't use 12 for the column. Okay. Minimum clear spacing 50, maximum center to center. I choose 150. Some people go 200, but I don't prefer to go 200. So maximum minimum reinforcement ratio 0.4%, maximum 4%. These all are code values. Link I choose 8 and 12. Okay, column okay. My minimum spacing 100, maximum spacing 12 time D, right? 12 time D is I prefer to limit to 300. I don't want to go 400. Increment 25 mm. In case you have the multiple layers, the column sometimes you have to put the 2 layers rebars, right? Then what's the spacing? Generally, we don't go 2 layers. Then I think okay, right? Confinement effect. I think you don't need this one now. Details settings, right? So these are the standard values. I leave it. Okay. So the link, how you want to provide link type, bar type. You want to choose this one or this one or this one. Link type, right? So normally we call this one, right? If you want this one, you can do it, but this one easy to do. Okay, general parameter is the same. The wall setting, no much different, right? So wall minimum rebar I changed to 10, maximum 20. These all are standard. I don't. The wall maximum percentage I changed to 4%. We can go until 4%, and so on. Okay, okay. I may keep it same all horizontal 2%, minimum of 2%, 0.2%. These all are basically, if you look at the code, the detailing rules, right, you can see all these values. Basically, these all are taken from the code. So if you read through the wall detailing, right, or beam or column or wall detailing, you can see all these values, right? Some are from experience, right? Some are from really from experience. Some values you can see in the code. The slab, okay, I'm not going to do the slab, so I leave it. Okay, foundations, right? I am going to use single footing, right? So I choose as isolated foundations. So foundations base, pad base, okay, minimum bars, okay, clear minimum, maximum I limit to 200. I don't want to go 400. So I call limit to 200. I don't want to use mesh. Reinforcement layout, found footing size. Okay, this is a standard footing size. Anyway, this we can just leave it. We can do the design later on. So anyway, file we don't need. Okay, so these are the main things we have done the checking. You say okay, right? So now let's go. I'm going to do the one design. Actually, it's a one click. You can design all elements. Later, we can do it. First, I want to do one element first, right? So in order to do, I go to okay, frame one. We can do on the plan also. Okay, I do the one on the plan, the column on the elevation. I choose this beam. Okay, choose this beam, right click on this beam, go to the interactive design, right? If you go inside, you can see static. Okay, if you have carry out the seismic analysis, then you can see two options, static or RSA. But now we have done a seismic analysis, so you can see only static analysis. Okay, so it's showing the error. Okay, never mind. We go and do by one. We choose one by one. Okay, so now you can see the screen. So first beam. So in the first left hand side beam, right? So here you had to choose a B rebar size. Look at the numbers 12. This number is 12, right? So 12. So one. First one is 12, right? 12 bars. Bar number 12. They have provided six numbers of S16. Okay, 6 numbers of x16 bars is showing pass. Okay, look at here, the required rebar 310 provided to 1206, six numbers of 16 diameter, so this bar, okay, this pass. Sunrise showing fail. Okay, it's showing fail. Okay, let's see why it's fail. Okay, sunrise, that means in the 3 is fail, it's showing fail, right? Where, okay, I think the reason is a clear spacing. Okay, so if you increase to 6 bar number, I want to choose 16, then it is pass. The reason is clear spacing, because you remember I have set minimum clear spacing 200, but based on the requirement is provided only 5, then that's why it's showing fail. Basically in the center you don't need any rebar, basically no need any rebar, but there's no, and the requirement is zero. You see, requirement is zero because no bending moment here, zero. But we had to provide the minimum rebars, so that's why it's showing as a fail. So after I choose the minimum rebar, it's showing pass, right? So it's a top rebar. Okay, now look at the top rebar. This one six numbers. This one six numbers. I mark it here. This one six. H16. This one also six, right? This one software shows 9. 9H16, right? 9H16. Okay. So now let's go to the bottom. Okay. Bottom 8, bar 8. Where's the bar 8? The bottom throughout bar, right? So it shows 12, sorry, 11. H12. I want 16, right? So I'm going to reduce the number of bars. So look at here. How much is required in the center? Required is 1246, right? We over provide, right? So I am going to reduce the numbers. Let's say I provide only 8. Right? So it's become 1608. So it's almost okay. So I leave it 8, right? Right? We don't need any additional second layer rebar, so it's 0. Okay, okay, I'm going to do this way. Okay, okay, you see this 16, 16, right? So if this beam is less than 12 meter, right? We can provide the one beam, one rebar throughout, right? Right, we don't need to cut here and so on, right? So what we can do is we can provide the 6 bars here, right? Then we can provide another layer here. Okay, it's all our detailing, or you can provide the 12 99 bars here, right? It's up to you to decide. Let's say you decide all 6 bars going through it, just 3 bars below, you can do it. That's why just I want to show you, that's all. But you don't need to follow the exactly same. Okay, see here is total 9 rebar is taking. Total is 9 rebar values. Okay, it's but it's yes, I want to give the example. I don't say it is a good detail, but just I give the example. In case you want to put a 2-layer rebar, then you can provide this way. Okay, these beam are very light, rebars are light, so you don't have any issue. But in case your rebars are very heavy, your spacing not enough, then you had to enter the two-layer rebar, right? That type, this detail is useful. Okay, I leave it, so I reduce to 9, change to 9. Okay, okay. So now these all are okay. Let's call the link. I clear it first. Link, right? So it's saying error, fail. Why is fail? Okay. So I want all
Spacing.
at 10. All at 10. You know the reason why is fail? The reason
Spacing.
is not spacing. Reason is I have chosen early in the design. I want minimum 10 link. So this when I change it to 10 is okay. That's why it's failing. Okay. So I choose it 10, right? Okay. Okay. Now you look at the it's the legs, right? So numbered legs, right? Because my beam width is 1000, right? 1000. So 1000 I want minimum 4 legs. So I choose 4 legs. Okay, central, let's see if 4 is enough or not. 4 not enough. So I go for 5. Okay. Okay. So this depth is 800. So I choose a sidebar also. How much sidebar I want to choose? Each face is let's say at the choose 3, 2 is enough. I think. So it's depend your design. So it's 2. I choose 2. Okay. So it is showing fail. Okay. Okay. If it says this problem, you can go and check it. Why is fail? First one. Longitudinal rebar. Sidebar. Sidebar. Why is fail? Okay. Maximum is facing is 283. Maximum. Our one is 234. So what we had increased the bar sidebars. Okay. Now you can see it's pass. Okay, now here you can see that utilization, right, is almost close to 1, right? It's not good. Okay, so let's come and see where's this problem. See, this rebar is very close. So let's increase the number of bars. So at least increase 1 bar, 10, right? Now utilization is zero point 0.9. So at least 0.9, 0.9 base 95 is okay, but close to 1 is not good. Okay, so let's go to the second span, right? Second span, what's the problem? Here, why is fail? Spacing is okay. Rebars are okay. Why is fail? Okay, minimum size, I think. Right. So this one I make it 8. Oh, 6. 6 enough? Let's see 6. Okay, 6 enough. Okay, so this one 3. Throughout 3, I'm going to use 3. So uh, L 9 or 10. Okay, 10. It choose 10. Right 7. Okay, 7. Middle 3, 6. Okay. So link, similarly, I choose 4, 5, 4, rebar 10. Okay. Now go to the span 3. So similar detail. Okay. This bottom rebar fail. Okay. Basically, I think is a diameter. So I change to 6. The previous one also I choose 6, right? Say 6. Okay. This one 6. Okay. Okay. Let's go to the final one. Final one. Middle fail. Why middle minimum bar? I so six bars. Okay, 6 bars. This one 9 bars. Bar 1 9. Okay, I use 10 because in the utilization very close. I choose 10. Okay, so top 3 bars. Okay, but side bars also I said 3. Okay, bottom I make it 16, right? So now look at the clear spacing. Earlier in the 12, right? The clear spacing we had a problem. Now it's 16, so okay. So in the clear spacing, so all okay. So we can, if you want, you can reduce the rebar maybe 9. Oh, I think 8. Anyway, this all you can play around it. It's already showing the all results here, so you can play around because you can see all required remark how much, and you can provide the based on the required remark how much need, right, design, right. So this one is basically all our detailing rules you got to follow. Right. So sometimes you may have a different opinion. Your detailing rules may be different. So you may have a different practice, but it's some okay. Some practice you don't need to follow same as me. You can follow your own practicing methods, right? So this way I am doing it. That's why I explaining this way I am doing it, right? You can change it. Okay, basically software showing you how much require, right? Then you can provide accordingly. Okay, so you can see this value. See here, this one is showing 4410, but I am overproviding. You may ask why overproviding, because I am following the basic detailing rules. Because this beam is 1 meter wide, right? So look at it, 1 meter wide beam, right? So that's why I provide minimum uh, 4 legs. So 4 legs means I have one outside, then I have one inside, right? So this one I maintaining minimum 300, right? So this one inside also almost 300. So it's all 900, so cover 50 mm, right? This is the way we are doing the detailing. So it's basically all the details, right? Okay, so now you see all are showing in green, so all are passed. So I click OK, right? Once you finish it, you can export this beam results as a drawing. Right click on here, see here, generate drawing. Click the generate drawing. So it's asking the detail, right? So let me export first. Later I come back and show you how to set up the drawings. Export first. Okay. So now you have produced a beam elevation. See, nicely produced a beam elevation, right? So the rebars are there, right? See, rebars are there. Okay, you may ask a question about how to set up these layers, right? You can basically it's AutoCAD drawing, right? You can see all layers, right? See, yeah, see, right? So set up the layers. I come back later on, so you can see all layers. So how to set up these layers, how to choose colors and line thickness, I come back later on. Okay. So also it's producing a lot of section. Basically, we don't need all these section. You can delete it. All right. So we don't need to produce a lot of. Basically, it's produce each section, each span is produced in 3 section. One, two, three, 3 section, right? So if you don't want, you can delete it, right? All this only. Then the good thing is here. You see, right? You calculate the rebar density. Sorry, the rebar quantity, right? How H10 how much, H16 how much, right? Basically, we have two type of rebar, H10 and H16, right? It's calculate total rebar. So in the particular beam, we want 1740 kg, right? So the you don't need to do on your own cost estimation and the quantity takeoff. So it's totally software calculate for you, right? So second thing is beam schedule, the bar bending schedule, right? So in the mark you can see later on. See each bar type how much quantity you want it, right? It's already calculated for you. So you don't need to go back and do all bar bending schedule. It's already calculated.
Sorry, we couldn't see the drawing.
Oh, you can see. Okay, okay. I think. Okay, can see now.
Yeah, so
Okay, sorry. If you don't see it, please let me know. I thought you are seeing. Okay, see this is a beam elevation, right? Beam elevation. You can see the beam elevation, right? So rebars, you can see the rebar, top rebar, bottom rebar, side rebars. Then it show the link. Okay, this is a total number of link, right? The Okay, H10 is a diameter, 20 is a type. Okay, later we see the type, and 300 is spacing. Okay, okay. So here you see this is a number 4 is a type of bar. So this okay, this type of the bar they call as number 4, right? So if you come from here, right, this bar they call as a number 13, type 13, right? This type 3, this bar called type 3, right? This is type 4. Okay, so all this bar, right, the bar bending schedule, you can see type 3, what's the quantity, length, diameter, right? Sorry, quantity numbers, how many numbers, total length, right, total length, the particular one element length, one unit length, right? This is a shape code also you can see. Okay, zero means actually, right, it's not covered in the standard bar bending schedule, so it's show as a zero. Other than this 34, 46, everything you can see in the BS code, bar schedule you can see in the shape code, right? Right. So these numbers, right, marked, right, is you can refer here. So here, H10, X16 means 10 numbers of H16, type 3, right? So this type 3 is a one straight bar, right? So you can see how much is the length, 4.6, 4.7, 4705, I think. Okay, let's go and see type 3, 400, right? Type 3, 1 unit length, right? Total 27 numbers. Total length is 126.9. Okay. Also, is has given the summary of the rebar quantity. H10 rebar how much? H16 bar how much? Okay. So they also is given the number of sections, right? So basically each span they have 3 sections, left, middle, right, right? Yeah, so actually it's a plenty of sections. You don't need many, right? You don't need to repeat the detail. You can delete it. You may provide a 1 or 2 sections. That's enough for your drawings. Okay. So after do the design, you can export your results. Okay. I close this one. Okay. Now can you see my Tekla Success design screen?
Yes.
Yeah. Okay. Thanks. Okay. So now I am going to explain how to set up the drawings, right? To set up the drawing, you have to draw menu, right? Go to that setting. General. Oh, sorry. Layer configurations. Wait, give me a minute. Let me check. Mm, sorry, layer style. Sorry. I forgot. Okay. See here drawings layer style, right? So member detail or plane, whatever, right? So here you can choose your own naming. You can change this naming basically. Or you can change it, right? You can change it, right? So for specifically, let's say beam detail, right? So click the beam detail. So here you can choose a beam detail, beam or column or whatever, right? So let's say beam detail, right? So here you can change it. Let's say your dimension line, right? If you want to change the name, you can change it. Color, if you don't want this color, you can change the color, right? You can change this whole color, the font size, everything you can change. This or everything the file layer, right, setting, right, you can change based on your company standard. You can change it, right? If after you save it, right, you can save permanently, then you can repeatedly you can use for other projects also, right? So this layer setting you can do here based on your company standard. I leave the standard one. If you want to change it, you can change it here. Okay. So all drawing setting you can do here, right? For example, member detail, I go to member detail, beam detail, right? So and the label style. you see underline beam label, right? Beam, if you want to underline the beam label, you can tick it here. Otherwise, if you untick it, it don't underline it. Label every span of multi span beam. Every span, if you want to label it, you click here, right? Then cross section, right? So cross section, how you want to change it? Capital A, B, C or small a, B, C or 1, 2, 3, right? You can change it, right? Then longitudinal rebar. If you want to show row bobs as shifted, or you want to change the single bar, right? Link similarly, right? If you want to change, you can do all these changes as here. Basically, this is for the drawing setup before you export it. After export AutoCAD also, you can change the setting. Okay. So now you understand how to do one beam design and export to AutoCAD, right? Okay. So similarly, I explained one column design. After that, I explained to you how to do the design at a one time, right? I choose one column, the center column. A similar way, right click, go to interaction design, select. Okay. So let's go and see one by one. Right, this is a top. Okay, C22 is a column name. Dash 3 means third stack. So if you have the doubts, you can go back and see that this column, right? So you can see this column we row from base to top, right? You can go and see the stack 1, 2, 3, right? Stack 1 is this one, 1 meter. Stack 2 is 4 meter. Stack 3 is 4 meter. Okay. If you have doubts, you can go back and check here. So what to interaction design, active design. So we come from bottom. So bottom, right? So let's see, right, this is a 400 by 600 column. So there's a bar, right? So look at the bar, 1, 2, phase 1, 2, phase 1, 2. We have count 1, right? That means the one bar is intermediate, that's like say called count, right? So clear spacing 149. I choose it 150, right? So I select 149. So okay. So all bar size are 16 diameter. See here 16, right? 2, 3, phase 2, 3, phase 2, 3, 3 bars, 1, 2, 3, intermediate bars is 3, right? 3, 4 is 1, 4, 4, 1 is 4, right? Basically. So let's say this one you reduce it 2, let's say 2, right? If you reduce it to, it's problem because the spacing we last time we said 150, so that's why it's an issue. But design base is okay, but based on the detailing, it's not satisfying. So that's why it's showing as error. So I change to 3. Okay. Then go to link, right? The link spacing, you can change it. 16 diameter, right? Main bar is 16 diameter, so minimum spacing 175, right? Bar size 8. Yeah, interaction, this is a design. You can see interaction diagram, bending moment. This is a moment, axial force moment diagram. So you can see our design forces are here. So it's safe, design safe, right? If you want to change the different low combinations, you can see here different combinations, how is changing it. You can see here. Okay. If you want to add any additional case, let's say if you have additional moment, additional forces, if you want to design for it, then you can add here and check back here. So basically the design curve, you can always check back. So I click OK. So if you want to see the detailed design, go to check, right? Click one by one. So longitudinal double rebar, go to one, or each cases you can check it. You see, this is ultimate axial force resistance. So if you expand here, you can see all the results. You can see it. How much is a compression capacity, how much rebar capacity, and so on. You can see. Then design moment. How my moment is almost zero, right? This is another direction moment, right? 42. This is a top moment, right? Middle, bottom, right? 3 level is do the design 3 level, right? Similarly, this each combination you can see the results. Also, you can see the different mark here, right? That means this combination is governing combination for the design. So you can see. Can go the bottom design is governing, so you can go and see the in case fail, you can go and check here why is failing, right? the bar limit check. So it's doing the whole check here. Okay, I close it. Okay, okay. Now I export this one and see the drawings. Okay, can you see the AutoCAD drawings?
We can see.
Okay, thanks. Okay, so this is a elevation of the big column. See, this is a column, right? Column surface. They have shown the rebar here. You see, here rebar. Okay, again, this detailing rule, right? You had to modify slightly. Okay, it shows the bottom because we have a foundation here, so it's showing like this. But it's all based on our foundation design, right? So this all you may need to modify it, right? So it's not perfect. We may need to modify this one. Okay. Then other than that is showing all lappings in the floor levels, right? So the lap length, right, is based on our design. Normally you can up counter check it this length, right? Okay. So it show the section everywhere. All floors show the at least one section. So you can see the section here, right? Rebar A, or H16. Basically, our rebar say H16, right? Also, you see, show the grid lines and setting outs, right? Okay, then same as beam, right? You can see the bar bending schedule and total quantity, right? Okay, so basically you can see most of the detail here. Okay, now I go back to software and do the designs. Okay, go to the design. Okay, just one click. Okay, you can see the analysis and design tab, right? Okay, choose a design concrete static. Okay, there's a two option: design concrete gravity and design concrete static. What is the difference? If you click the design concrete gravity, right, it's only designed for gravity load combinations. If you want to include the lateral load combination, then you're supposed to choose design concrete static. If you do the seismic analysis, then you can check for the design concrete RSA also. But we haven't done it, so that's why it's inactive. So I'm going to choose design concrete static. That means gravity load plus lateral loads. So I choose this one. So now software running. So it's do the all the concrete element design. Let's wait for a while. It's taking some time because it's doing all design at one time. Okay. After done it, you saw it, right? It's called results review. So if you click on the tab, right, you can see results view, right? The results view, the green means pass, yellow means warning, red means fail. Okay, let's go one by one, see, right? The first one is a warning one. So I choose this one, right click and go to interactive design and check. What's this? Why is this supposed to be okay? Why is showing? Why is warning? RSA. Why? Let's go and see. Okay, check. Okay, check. Okay. Let's see why it's what's about deep beam. Okay. See, because our span is very short, that's why it's giving the warning based on the code. It's supposed to design as a deep beam, right? So okay, so now it's your decision, your judgment whether this one is okay or not, right? So if your decision is okay, then we can leave it, we can ignore this warning, right? So basically you have to look into it, things, right? See, this fan over depth ratio, right? This very we have chosen very big beam. It's actually is our error. So see, this beam is only 200 and 250 by 500. This one we provide a very big beam. So 800 D beam is span only 2.5 meters. That's why software giving the warning is this is this one considered as a DP based on the Eurocode. So we support it to the judgment. Okay, if you say this one okay, ignorable, then we can ignore it. Basically, it's okay, no issues, right? So we can leave it this one, right? Okay, then now let's go and see the fail beam. Why is fail? Okay, I click on here, go to check member. Okay, so let's see why is fail longitudinal bar. Okay, it's a bar problem. Okay, so we go and see the interactive design. Okay, same as previous one. I quickly change the rebar sizes, right? Same as previous. I change it quickly. So this one I already explained. So I quickly do it. Basically, I want to show you uh, how to uh, prepare the schedule, beam schedule, right? So that's why I quickly do this one. I don't care. I change the rebar quickly. Now you know how to change all these things, right? Okay. Okay. So this one okay now. So we choose this beam, what interact design, second span, what's the problem? Link, okay. Link fail. Why is fail? Required provided, okay. Oh, this I make it for. Why is fail? Limit check. Go to check. Link ceiling limit. Maximum allowed spacing is 300. Okay. Maximum allowed spacing 300. Okay. Why? Links spacing across beam region 310. Okay. So we had increase the number of legs. Okay. So we increase the number of legs. Okay. Click. Okay. So sometimes it's so error because of the detailing rules. So you had to careful on the detailing rules. Actually, it's good now because some software is not checking the detailing rules. So then you don't know whether it's okay or not. But here is a good thing is checking the all detailing rules. So you can easily counter check. Okay, I don't explain because you guys know how to do all this one. I quickly change it. So I want to export to okay. 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 So now first story beams are all are okay, right? So now I am going to prepare the beam schedule. Okay. Some of you may not familiar with the beam schedule, so because you may probably produce only the elevations, right? But sometimes, right, we don't produce the elevation. Okay, if beams are typical, then we provide the schedule. right? So let I show the schedule. That's why I do the quickly set up all the beam rebar, right? So I am going to produce a schedule. Okay. So before that, I am going to create a group, right? So if you got to create a group, right, you got to go to the project browser. Okay. If you look at the below, right, there's option. First one is a section. Now we are seeing. Next one is a group. Click the group. Then go to the design. The group under the group, right? You have a detailing group. You have a design group, right? So go to the design or detailing group, right? I saw the design group. So cast institute beam. You can see the cast institute beam, right? So you can see the lot of groups here, right? So it's many groups, right? So what I am going to do is I am going to create the one new group called I am going to call first story beam, right? So the group I call rename uh, L1 beam, or you can call first story beam or L1 beam, whatever. Okay. So inside, okay, sorry, the schedule you are not supposed to do like this. Actually, what you want, because each beam we want the separate detail, right? So what we want to do is already group it, we split it, everything we split it. So just split all the groups. So it's all the beam become a individual beams. So I split it, split, split, split. Okay. Now I think all become individual beams. If you want, you can change the naming later on, right? So, okay. You see, this I you can change. I can change to one B5 because in the schedule is showing the group name. So this is a problem in the software. So you have to change the naming. Uh, Rename. One, two, B4. Right. So likewise, you can change it, right? So I'm not going to spend the time here. You can change it. Okay. Okay. So now let's go to the drawings again, right? So draw, go to draw. So now you can see the schedule, beam schedule, right? Under the schedule tab, you can see the beam schedule, right? Okay. So yeah, what I'm going to do is before that, I want to create a group. So I go to schedule management. Can you see beam schedule? But I add the new one and the name I changed to first story beam schedule. Beam schedule, right? So the content I'm going to select it. Okay. See, I'm going to select this one. Right, this one. Okay. Level 2. All first story beam I'm selecting now. The problem with this software, the group, right, is not very user friendly. You have to do manually. That's the problem. In future, they may improve it, but currently, is you have to do manually rename it. So I'm choosing all the first story beams, so we can produce a first story beam schedule. Okay, I think I already create all the first story beam I already chosen, right? I choose all the first story beams. Okay, 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 click OK, right? Okay, so now let's go and create the beam schedule. Click the beam schedule. So let's create the beam schedule. Okay, so now you see, right? See here, right? Beam first story one, B1 dash one. It's the first span, second span, third span, fourth span beam, one B1 beam. So here you can, if you want, you can see the span type. First span, internal span, and end span, right? Then the rebar detail. Okay, bottom rebar normally they provide only the center. If you want, you can copy it copy left and right. Basically, it's the same rebar detail, so you can copy on left and right. Right, top rebar they show left, center, and right. Right. So you see in the bracket 25% is minimum rebar. They provide the minimum rebar. Okay. So it's okay, showing the all details. If you don't want something, you can delete it. So if you look at here, right? Normally we show only 8 H16, right? We don't show this one 35, right? So, but it's showing the bar type. If you want, you can delete this one, right? Similarly, link also is provide the center how much. Then if you want, you can copy left and right it. Okay. Sidebar, wherever need sidebar is provide the sidebars, right? Okay. So you can see the member sizes, width, depth, how much member depth, width and depth. Okay. So this is a all first story view. Okay, so in the bar shade, bar bending detail, right? You can see reference, right? Reference, right? So 35 so bar means this shape, 60 means this shape. So it gives the all the typical detail of the bars, right? This is the general notes for the bar bending schedule, right? So basically, it gives all the detail. Okay, sometimes, right? Okay, it's if it is your preference. Sometimes we produce only the schedule. We don't produce all beam elevations, right? So if you want to produce a schedule, you can produce it. If you want to produce a beam elevation, also you can produce it. Okay. Okay, so far I have shown you how to produce a beam schedule based on the group, right? I create a group and do it, right? If you don't want this create, right? If you want to see everything, right? What you can do is you can do here also. Let's say I want a second story, second story, right? So I'm going to produce first story and second story. So I click select the content, all content, first so all second story beam. Let me see. All are selected or not? I think all selected. Okay. So now we are going to do produce second. Also, I okay add third story also. Then we can produce all beam schedule. Okay. So select all. Okay. So basically all the other story. Okay. So now go to beam schedule. So we can see all the beam schedule. Wait, why I cannot see? Oh, let me go back and check. Okay, we had to produce one by one. Sorry. Okay, now you can see all the second story beam, right? All the second story schedule you can see. Okay, passage you can see all the second story. Similarly, if you want a third story, go and see the third story beam. Okay, so you can see all the circles, sorry, beam schedule.
When we generating the beam schedule,
Hmm.
uh, uh, it, uh, typical drawing will not produce, right? To refer
Yeah,
the
yes,
number.
okay. Yeah, it's not really produced. Okay, if you want, you have to go back to detail and where you want to go back is settings. Let me show you. Right. Uh, Drawings is under design. Sorry, under got the design settings. Beam reinforcement setting detailing top. Okay, this pattern basically they follow this pattern, right? So T1, T2, T3, basically you have to produce your own pattern based on this one. You have to produce your own drawing based on this one. They are following this pattern basically T1, T2, T3. The top bottom also similar. So B1, B2, B3. So they are following basically this pattern. So if you want a typical detail, then you have to follow, you have to produce a drawing yourself based on this one. Okay.
Okay.
Okay. So next one is okay, it's similar to, same as a beam, right? Because you can produce a column, right? So first I just click the column, just click it and so how they are. Okay. See column, right? They have a two group only, right? Two group. It's automatic selected, right? If you okay, if you don't want these two group, if you want every column individually, right? What you can do, you can split it, and then you can group yourself, right? But I just click to and go and just show you how it look this column schedule. Then you can do your own column schedule, right? So you know how to do it. Right? Split the column, all the column first, then regroup it, right? Okay, so here, um, okay, see all the columns you have it. If you want to group it, then you can group yourself, right? Then you can print it one group, right? But it's showing all the column basically, right? The column, all the column in the schedule. If you don't want to see the elevation one by one, right? Normally column we go with the schedule. We don't provide the elevations, right? It's unnecessary, right? So you can produce this one, right? So after design, you don't need to do any drawing, no. You can straight away produce your drawings, right? So similarly, column beam schedule, you can see the summary, right? Basically, you can see how much is the total quantity of rebar, right? Okay. So you can see all these information, right? You can review yourself. I basically show all the information. If you want to change this one, you know where to change, right? You got to go back to the layer setting and you got to change it, right? If you are not happy with this font size style, then you can go back and change it. So basically, if you want to do the change, right, just click here, look at the layer, right, this layer, then go back to the setting and do the changes on the particular layers. Say, see this color, you don't like it, right? Then you can change the colors, right? This link, look at this link, right? This one I have chosen, right? I want this type of thing. If you want to close this one, right, then you can choose that link, right? So all everything you can it can be customized based on your needs. Okay. So I think I have only 10 minutes, 10 more minutes. Okay. I think, okay, I already covered beam and column, right? So wall also similar. You can click wall, right? You can choose all the walls, right? Produce a schedule. Initially, I plan to cover the foundation design also. I'll try. Yeah, see, the column very sorry, wall very straightforward, right? So it's basically showing all the sections, right? Each floor so a section, right? So you can see the rebar, right? It's basically it's a practice. Even though I explain everything, if you don't practice it, then you cannot understand what is going on. Okay. So better you go back and practice this one, right? So quickly cover the wall design. I think I haven't explained anything on the wall design. So I quickly select one wall, maybe wall W1, select, go to interactive design, right? Here I go to level one, right? So I choose a minimum bar, 10 diameter, right? 10 diameter, right? So number of rows, right? The clear spacing 150. Let's say I reduce it 50 mm, 50. So clear spacing become 200, right? So it's showing error because I have chosen 150 clear spacing in the setting. So if you change it 200, then it should be okay. So I change back to 150, right? This one okay. This way rebar, so we don't provide anything. Now lateral link. So if you want to provide the lateral link, you can provide it. Interaction diagram. It's almost same like the column, right? So you can change it. If you want, you can change it. Okay, let's say if you want to reduce the thickness or if you want to do the optimization, actually you don't need to go back and redo the analysis. You can change the sizes and see it here. You can change it here. Then if everything okay, then you can change and do the analysis again. Because if you change the size, it may affect analysis. But if you want to check based on the already exist results, right? You can check it here. Okay, I cancel it. So it's a wall design. Okay, I quickly go and do the foundation design. Uh, okay, foundation design. I think I made a better start next week. So today I will cover. Okay, now you know how to produce a schedule, right? So I'll show you how to produce a general arrangement and foundation rejection. Right? If you want to do the file design, you want to find foundation loads, right? So I capture this one. Next week I explain the fat routing design. Okay, so everything I go back to success review, right? All our success review. Okay, so let's go and do create a general arrangement. That means our layout plan, right? So for let's say first story layout plan. I want to produce a first story layout plan. What I want to do is click the general arrangement. Okay, so it's producing the first story layout plan. So okay, okay. See, it's already produced for you, right? Okay. So it's showing the beam sizes, member name, and everything is showing. Okay, now you want to ask me a question. Okay, why this beam is showing dotted line? This one is showing the solid line. It's supposed to be a dotted line. Am I right? The reason is here, right? I saw you in 3D. Okay. See, our slab is located is above. Actually, is mid now. So this side is okay. One side is okay. Other side not okay. The reason is okay. I saw you why. When I select this beam, go here, go to the alignment. Okay, major snap. I make it center. So if we make it stop, so it being lower down. So this one aligned to the slab. Right, this one I think already done. This one already done. This one is supposed to be done. Okay. So I believe first story also changed. Let me double check. So let me double check. Okay, now go back to first story and produce a general arrangement again. Why? What's error? Okay, okay, okay. Now is okay. See, all are dotted line. Outside is solid line because slab is stopped here, right? So outside is solid lines. Our slab is not overhang, so it's solid line, but internal also are grid lines. See? Okay. So now we are producing our plan. So you don't need to go back and produce a drawing again. So you can produce a drawings straight away. So from here you can touch up it, you can share, modify it, but basically you have the base plan. Right? Similarly, you can produce other plan, other level also, right? Okay. So beam and forces, right? Similar, I already say, but if you want to do the steel design, then you can export the beam end results. So I'm not going to cover here. So foundation reactions. So I go to the foundation plan. I saw the results. You know how to go and see the results, right? Results view, right? Select the reaction, right? So I choose FY, right? So I'm going to choose an envelope, geo envelope, right? So now I want to see the text, right? So go to the text and so select the reaction. So each point you can see the results now, right? You can see the results now, right? So why is showing two results? Because we choose the envelope, so it's showing a maximum and minimum. So now go to the row and create a foundation reaction. Okay. So zoom up and see. So it's showing all the results. How much horizontal, X, Y, and Z. So it's giving the range. Okay. So there's no moment. So it's basically zero. Understand? So look at the base foundation geo combination. We choose a geo combination, right? Okay. So you can straight away send this drawing for geotic engineer to do the file design if you want. Okay. Next week, let's see how to do the fat pudding design. So fat pudding design you can do it straight away, no issue. So if you want to do the file designs, you can export these results and send to the geotech engineer so they can do the file design based on this loading. Okay. So basically, if you do the if you do the modeling correctly, right, then you don't need to do much modification in the AutoCAD drawings, right? Most of the things will automatically produce. Okay. Okay, if you want to produce a loading plan, also can. So what you want to do is, okay, you have to select the load case. Let's say impose load. You have to produce a live load case, right? Here you cannot see much because I have applied the uniform load, right? So if I export it, you don't see much. But if you apply a different load case, a different loading, right? Then you can see the nice loading plan. So basically here now you can see the note, one note only. Slab load is 3 kN per meter square. Okay. If you had doubt, you can go back and see this loading is 3 kPa. Right. But if we have a different loading, then it has a different catching and so the annotation here. Okay. So you can produce a loading plan also. Okay. So the finally, okay, we haven't done any raw foundation, mat footing. So finally, it's a foundation plan. So this one I make as a non, right? I go to structural view. So if you want to produce a foundation layout, after create a foundation, you can produce a foundation layout. So next week I will cover this one, how to produce a foundation layout. So before that we had to produce a file pad footing design. Okay, I think that's all today. You have any question you want to ask me? Or do you want to cover any other topics? Because this is almost the end of the Tekla structural design. Next week, I suppose we start the example building. So I want to do the framing plan. that means member sizes. After that, I go to the Revit and do the modeling. Then we come back to the Tekla section, do the analysis and design. That's my plan. So you want to cover any more topic in the Tekla section designer? Please show slab detailing. Okay, I will try to cover next week. Okay, basically, flat, if you want to do actual slab design, right, you have to model flat slab, right? So if everyone are okay, next week I can cover the flat slab design. But problem is my plan next week is framing plan, right? So if you go and do the flat slab design, then I had to push back that framing plan to next week. So is may you may discuss inside internally in the group. If everyone okay, I can cover the flat slab design next week, right? Okay, if you don't have the horizon, then we can find cannot be produce beam drawing directly like column. Cannot be produce beam drawings directly like column. Actually, we have produced a beam drawing, right? I don't understand which drawing you are referring. I saw you the one of the beam elevation,
Sir,
right?
you saw that one that what I'm asking, sir, for the column section drawing you have shown like that the beam drawings can be produced.
Uh, uh, okay, beam we can produce an elevation. Also, we can produce a schedule. What other drawing you are looking for?
Sectional drawings,
Sorry.
sectional drawings, sir, you saw the
Okay, I produce now and go back to the drawing. You can see the section. Okay, can you see my AutoCAD drawing now? Hello, can you see my AutoCAD drawing?
yes.
Okay, so after this elevation, right? The elevation they cut the section A, B, C. So in the sections are here. See, this is section. This is what you are looking for, right?
Yes, sir. Yes.
Okay, so you can see the sections here. The same elevation, you can see the sections.
But the question here, do you want me to produce one by one?
Yes. Beam elevation you had to produce one by one. Correct. Only schedule you can produce all together. Actually, you can group and produce it if you want. You can, what you can do is, if you want, right? I close this one. What you can do is go to drawing management, right? Select beam details, right? Add, okay. You add the name, whatever name, right? Go to content, right? So let's say you want to produce this one, right? B1, right? B1, you are producing it, right? Okay, so click OK. So this one you provide the name B1 beam detail, 1B1 detail. Then you can group together and you can create it. This way you can do it. But it's manually you got to do it. You got to do one, you got to add one by one and do it. Okay. Okay. Okay, then let's bind up here. So next week, first I say I continue this model and do the fat footing and export the foundation layouts. Okay, then you discuss your internal your group whether you want whether I want to capture the file plus lab or not, because plus lab is not my scope. Earlier I haven't decided, but all of you are interested. If you want to know about plus lab design, then I can go ahead, no problem. I can spend one day to finish it. So later we can start our modeling next week. Okay. Okay, that's all, Sagaran. We can wind up, right? Okay, thanks.
Okay, thank you.
Okay.